Hi everyone, welcome back to my YouTube channel. Do you know what SWAT model is? How do we predict the impact of land use changes and climate change on water resource? What tool can we use to model water balance, soil erosion, and water pollution in the large watershed? How can we optimize agricultural practices to reduce environmental degradation? The answer to all those questions lies in the SWAT model. Let's dive into what SWAT model is, how it's work, and why it's widely used in hydrological studies. This course provides a complete step-by-step guide using ArcSWAT in ArcGIS for watershed simulation and analysis. Let's start it. First, we'll start with downloading ArcSWAT. Open your browser and type ArcSWAT. Press enter. And we have the first option, ArcSWAT Soil and Water Assessment Tool. Select this one. And in the main page, we have different options. If you are willing to download ArcSWAT or ArcGIS Pro, you can download it from here. But in my case, I'm using ArcGIS 10.3. So I scroll down here and press here, select your ArcGIS version. And I'm using ArcGIS 10.3. Select this one and download. It's start downloading. After we download ArcSWAT, let's install it. Open, navigate to where the file downloaded, ArcSWAT. Extract file. Okay. Then this is a file. Installation. Select this one, SWAT install. Say okay. Agree. Okay. Here we have two options. If your computer has been used by many users, select everyone. If just you, select just me. Okay, next. Then next. It will take some time and install ArcSWAT. Yes. Done. Close. Now ArcSWAT is installed. What we'll do is open your ArcGIS, ArcMap. It is loading. After we install ArcSWAT, we need to active ArcSWAT in ArcGIS. Let's say okay, cancel. Right click and select ArcSWAT. And before that, you have to make sure all ArcSWAT features are activated. Select Customize, Extension, and extension we have SWAT HRU and SWAT Project and SWAT Watershed. Check this, close, and right click here and active SWAT. Now SWAT project is here. We have SWAT project setup, watershed delineation, HRU, write input table, and edit SWAT input. And finally, we'll go to SWAT simulation. So before we go further in ArcSWAT, let's download some files which is required to run SWAT and configure SWAT in C drive. Okay, select Chrome and type ArcSWAT again, ArcSWAT. Same what we have done before. Here go down, we need to download global weather database. This file gives average climate data for the past 35 years worldwide. Download. It's downloading. There is some other data we need to download alongside with global weather database. Go to data And in data, select India dataset for SWAT 2012. The data is saved in India dataset, but the soil water base for entire world download. It's downloading. And there is another data is required to run SWAT, and without this data, SWAT cannot run properly. It's SWAT 2012 database, right? SWAT 2012 database download and go to this website, India Remote Sensing and GIS. The data is for all over the world. Click here to download update SWAT database. Is downloaded SWAT 2012. Let's open our folder. Yes, SWAT 2012 extract file. Okay. Soil water base extract file and world database. Okay. So we have the required file to configure ArcSWAT. Let's copy and paste it in particular folder for ArcSWAT. I already made folder here. SWAT model. Save it. Those the data required to run SWAT. Those data I will share it in Google Drive. Can easily use it. So let's first start with soil water base. Open and open SWAT 2012. Double click. Okay. Enable content. Search for user soil. Scroll down. User soil. Double click. This is the user soil for entire world developed by FAO. Scroll down. Click shift. Copy. And then go to the C drive where the same SWAT 2012 in SWAT is saved. Go to C drive. SWAT. ArcSWAT. Then database. In database, we have SWAT 2012. Double click. Okay. Enable content. Search for user soil. User soil. Double click. The user soil over here is for US. So we want to replace it with soil water base for entire world, as our area study will be different from US. Click here and scroll down. Delete. Okay. And paste the data we already copied from the SWAT 2012 base. It's loading, takes some time. In progress. After pasting and saving those files, then the SWAT will start reading. Done. Are you sure you want to paste those records? Say yes. Now done. And save your data. It's saved. Cancel from here. Okay. Okay, done. Then after we prepared SWAT soil water base, we need to prepare global weather database. Go to ArcSWAT weather database, double click. Here, enable content. What we see is WGEN weather database for US, and we need it for all over the world. Go to external data, and in external data, select new data source from database, access. Here, browse to where your data is saved. The global weather database we saved in SWATmodel in SWATmodel. This CFSR world. Select this one, open, and leave it as it is. Okay. Then select WGEN world, click OK, and wait until import the data is importing. Yes, done, and close. Now we see WGN CFSR world is being generated successfully. Now close. Now the SWAT model is ready to use. Close this one. Open ArcGIS. Solid the SWAT model, we configured all the required support file and prepared the system. Now it's time to prepare the input needed to run the model. This is crucial step, so follow me carefully. What the input data required to run SWAT model? To run ArcSWAT successfully, we need 4 essential input and 1 more for calibration and validation. The required input data is digital elevation model and land use, land cover map, soil map, and weather data. And finally, we need stream flow for calibration and validation purpose. Let's go through each of those step by step, and I will also share my recommendation and source for downloading them. The DEM will be used in SWAT model to define the watershed and topography. This includes stream network, slope, and subbasins and boundaries. For this tutorial, I will download DEM and land use land cover from DivaGIS because my study area is relatively large. In your case, I suggest you to download land use land cover and digital elevation model from USGS Earth Explorer. If you want high resolution and more accurate result, always download your digital elevation models from the official USGS website via Earth Explorer. There you will find data with a 30-meter resolution, which is ideal for most hydrological model. But for the tutorial purpose, I will show you how to download DEM from DivaGIS, and I already prepared tutorial showing that how to download DEM and land use land cover from USGS, and I will leave the link in the description box. So let's get started. Open Google Chrome and type DivaGIS. Yeah, DivaGIS by country. Open Google Chrome and type DivaGIS. DivaGIS by country. Select DivaGIS. This will take you to the main page. This is the main page of DivaGIS, and the advantage of using DivaGIS is providing different topography data for country level. And my basins is too large, so I will download digital elevation models and land use land cover for 2 countries, Sudan and Ethiopia. Select here and search Sudan. Select elevation. elevation by mask. Click here. In the format, select format geotiff. Press download. Cancel this. Start downloading. And again, land cover. Search for land cover. Download. As my basin is too big, I need two country. Search for Ethiopia. Ethiopia, and then press download. And again, we need elevation. Download. So now we download digital elevation models and land use land cover for both country, Sudan and Ethiopia, where my basins is located. One more file is needed, soil map. Can download soil map from the official FAO website. Right, FAO. Select FAO soil map and here digital soil map of the world. There is some problem in the website, but no problem. I will share the world soil map I already downloaded before. I will share it in Google Drive so you can easily download. Let's navigate to where our data is downloaded and extract the data. Extract the file. Okay. Extract the second file. Okay. Extract file. Okay. Done. After we extract all files, let's copy those files and save it in the SWAT folder. Copy. SWATmodel. SWATmodel and paste it here. And copy the land use land cover and paste it in LULC. Copy the digital elevation model. Copy the digital elevation models together and paste it in DEM. After we successfully downloaded land use, land cover, and digital elevation model, there is further process need to be done. First, navigate to where the data is stored. From here, go to SWAT model in eDrive. SWAT model. Let's start with DEM. This the first DEM. Add. Again, the second digital elevation models. Go back. Add. Yes. Zoom out. Or right click here and zoom to layer. Yes. First, we need to mosaic those two digital elevation models. Select catalog, system toolbox. In system toolbox, select data management tool. In data management tool, select raster. And in raster, select raster dataset. And then mosaic to new raster. Here in mosaic to new raster, add your input data. The input data is first add the first DEM and again add the second DEM. And the output location, specify where your data to be saved. And go back, select the file DEM and say add. Now output location is added. Then we need to type raster dataset name with extension, right? dem .if for raster. This is a raster extension, and a special reference for raster is optional, and we can add it from here. Geographic coordinate system. In geographic coordinate system, go to world. In world, select WGS 1984. Okay. And here the pixel type is written 8-bit unsigned. To ensure that whether this is correct or not, just go to digital elevation models at the left side. Right click, select properties. In properties, select source. Scroll down here, source type genetic, and the pixel depth is 64-bit, and the number of band is 1. Say okay and add it here. Change this one from 4 to 64-bit. Cell size is optional, and the number of band is written 1. Add it 1. Then the rest is fine. Don't change anything and select OK. It's processing. The process is done. And second step, we need to add the basins, so we can extract our basin, which is cover those two country. From here, select basins, and we have BN basins shape. Okay. Yes, let's change the color. Okay, it's fine. And then go to special analysis tool. Special analysis tool. Yes, special analysis tool. Extraction, and select extract by mask. From here, the input raster is digital elevation models, and then the input raster feature is the basins, and here select the output location is in E drive, SWAT model in DEM, select DEM, write DEM basins, basin.tif, save. Okay. Yes, process is done, and uncheck the previous DEM and uncheck those is no longer needed. This is the digital elevation model. Delete this one, it's no longer needed. Remove this one, remove, and this also is no longer needed. Remove. And next step, we need land use land cover. Click here and go back to land use land cover is LULC. Select the first LULC. Okay, add, and again go back to second LULC, add. Do the same process from catalog. We need to mosaic to new raster in data management tool. Select the first LULC and the second LULC. Output location LULC. Go back, and you have to select the folder from outside. Add raster name with extension. Type LULC.tif. Special references for raster. We do the same geographic coordinate system. World WGS 1984. Okay. And here, to specify whether this is correct or not, we do the same process. Go to DEM and properties, source. It is 32-bit, but it's floating point, not sign. It is floating point, 32-bit. Okay. It's not unsigned. Change this one to 32, float point, this one, 32. Cell size is optional, and number of band is 1. Rest is fine. Okay. Done. And let's remove this one and remove this one as well. Oh, not this one. Remove this land cover. Remove this one as well. Okay. And now we need to use the basins to extract the location. Go to special analysis tool, extract by mask. Okay. LULC, basins, output location. Let's save it in LULC. Here, LULC, basin dot diff. Okay. Okay. This is the LULC. Uncheck the LULC. Okay. Remove LULC. Now LULC and DEM are ready. We need to classify the LULC. And to classify LULC, we have different classification. Supervised and unsupervised classification is here. We see classification. We see the classification. If this option is not appear in ArcGIS, just select the plain area here and search for image classification and check this one if it's unchecked. Then select classification, and we need, and then select this one, unsupervised classification, ISO cluster unsupervised classification. Select the land use land cover here. By default, select DEM. Delete this one and select LULC. And number of classes is based on the classes available in your study area. And I have around 10 classes. Write 10 classes, and if you have less or more, type the number of your classes in your study area. Here, select the output location is land use, land cover, LULC. Type here LULC classified dot diff. Say okay. And rest is fine. Select okay. Okay, the classification is done. Next step, we need to import soil map. Select this icon and search for DSMW. This is the soil map we need, and we need this one, DSMW shape. This is the world soil map, and I will make sure that I will add this in Google Drive because there is some problem in the FAO soil map. Okay, select this one, add. Yes, this is the world soil map for the entire world. Yes, zoom to layer. Yes, and what we'll do is to extract to our location. Do it from here. Go to geoprocessing. In geoprocessing, select clip. So in this option, we have input as a feature. Then add the DSMW and the clip feature is our basin. Okay, and here select the output, let's say soil map. Here soil map, say okay. It is not .diff because it's a feature, it's a shape feature, and select okay. Yes, it's done. And check the world soil map and delete it. Zoom to layer. This is a world soil map. We can change those classes from properties. Go to symbology. In symbology, go to categorize unique value. From here, select this one, DOMSOL, add all values, apply, okay. This is the different soil map classes. And what to do next is to convert the shape of the soil to raster. Go to conversion tool, conversion tool, select to raster, polygon to raster, polygon to raster, soil map. Here, yeah, check this one to select CNUM. Okay, here select CNUM and raster output. Raster output, right soil map basin. Okay, rest is fine. And if you need to change the cell size, you can change it from here. You can make it 5. You can increase or decrease the cell size from here. It's up to you. Select OK. Now we got soil map. Just uncheck this one, the shape one. This is the raster soil map. We can change it from here. Go to properties again, and in properties symbology, classify and unique classification, add all values, apply. This is the number of classes we have. Say okay. Yeah, the soil map is ready with different classes. Okay, and next step, we need to reproject soil map, land use, land cover, and DEM to UTM zone, because the SWAT model cannot work with a WGS. It's work for the UTM of your specific location. To do that one, go to data management tool, close this one, go to data management tool and search for projection and transformation. Let's close this first. Projection and transformation, and in projection and transformation, select raster, project raster. Yes, in project raster, the input data, let's start with DEM basin. This is the coordinate system we specified before. It is WGS 1984. Okay, this is the output location. Let's say DEM UTM. For UTM zone, the output coordinate system, go to projected coordinate system. In projected coordinate system, select UTM WGS 1984, and north. In my case, the basin is located in north hemisphere. In north hemisphere UTM zone 36 north is 36 north. Search for 36 north. Say okay, and rest is optional. And if you want to change the cell size, you can change it from here, but I leave it as it is and say okay. Now the DEM is projected. This is the projected DEM. We don't need this one. Remove. Okay. Next step is to project land use land cover, and we use the same method. Select LULC classified, and output is LULC UTM dot tif. Okay, and output project coordinate system UTM zone WGS North Hemisphere 36. Okay, rest fine. Okay, yeah, done. And then soil map, same way. Soil map basins. UTM. Okay. UTM zone WGS 36. Okay. Okay. Properties. Symbology. Unique classification. All values apply. Okay. Delete this soil map basins. Okay. Basins is no longer needed. Delete this one. Now LULC, DEM and soil map is ready. Next step, we need to prepare the weather data. To prepare the weather data, let's first create different folder for each variable. I already have folder over here. Just copy this one and paste here. Each folder should have a unique value. PCP for precipitation, relative humidity, solar radiation, temperature, wind, and it's up to you to prepare your code. It's not mandatory to do the same. To prepare those data, first let's open the CSV file we downloaded from our NASA. Double click. Okay, it's open here. To separate those information from the variable data, let's copy this, scroll down to the end of the value, shift and right click, copy, and then new file. Let's open new Excel file. Here, Excel sheet. Open the new Excel sheet and paste the selected variables. Okay, here. I did this process to make sure that we have some information here. We don't want to lose it. It's like the elevation and latitude and longitude. Okay, save the file and drag it in this site. Let's open precipitation. Open precipitation, new file, and text document, and give it name of your station. APN is my first station. Open the file, open the previous file from here, and let's start with precipitation. Copy and paste it here. Paste. Go to the first and change this one to the starting date of your values. My data start from 1997 0101. It's January 1st. Save the file. Done. Close this one and copy the file. Copy and go back to relative humidity. Paste. But the data over here is for precipitation, and we just convert the data over here is for precipitation. We just copy the relative humidity data, copy, and scroll down, shift, delete this data, and paste the relative humidity data. Change this to 1997 0101 and save it. Save. Close this one. Go to solar radiation. Paste here. Open the file. Let's paste the solar radiation data. This all sky. Copy. Let's first delete this one. Shift, delete, paste the solar radiation data. Change the code 1997 0101. Save. Solar radiation is done. Then wind speed, paste. Wind speed, paste. Open the file and wind speed. Yes, wind speed at 2 meter. Copy. Scroll down. Shift, delete the data. Paste the wind speed data. Change to 1997 0101. Save and cancel. Go back. And last is temperature. Open temperature. For temperature, we can copy and paste our value like the previous variable, because we have temperature maximum and minimum. And what to do is go back, copy this file, copy and paste it here in temperature. Open the file. Okay, this is our data. What we need is, let's delete this one. Delete, and delete relative humidity, precipitation, and wind as well. Okay, now we have temperature max and temperature minimum. And make sure this file is CSV file. To convert this file to CSV format, press File, Save As, Go to Excel, go to CSV, delimited, and save the file. Okay, cancel this. Change the extension to txt. Okay. Yes, done. Open. Yes. Temperature max, temperature minimum. Change the date to 1997-01-01. Save. Cancel this one. Delete this one. And then we can change the file name to the station name APN. Copy. AMBO. Second station. Go back. Now I show you how to prepare weather data for precipitation, temperature, relative humidity, wind speed. I just explain how to do it for only one station to save time, and do the same procedure for the number of stations in your basins. In my case, I have 22 stations, so I will just copy and paste the station over here. Next step will prepare the batch code, which is essential for SWAT model. Open the Excel file and open new file. Delete those two columns. We need to develop new columns. Delete. Let's start with preparing the code. First, we need the ID, is the name of the station. Third is latitude, lat, long. Last is elevation. And we have two stations, station 1, station 2. I have 22 stations, but to minimize the length of the video, I'll show you only 2 stations, and remaining I'll prepare it myself. The first station name is APN, and the second one is AMPU. The latitude for the first station, the file over here is the information of the second station. We have latitude 13.97, and longitude is, and elevation. Close this one. Open the second file. This is the second file. We already write it down. This is the first station. Drag it to the right. Latitude is, longitude is 34. Elevation. This is how to prepare the code for SWAT. Delete this one. And then convert the file to CSV. Name it as PCP patch. Okay. Close this one. Go to precipitation. Yeah, this our file. Change the extension to text txt. Okay. Yes. Open. Yes, this is a format so I can understand. Cancel this one. Delete this one. It's no longer needed. Now you know how to prepare the weather data for each station in your basins, and I copied all stations I have in my basins over here, and 22 different stations in my basins. Let's open the PCP and show you how it look like. This is a batch code for each station. I have 22 stations over here with ID, name, lat, long, elevation as I explained it before. And make sure that all stations available over here, their name is the same name in the batch code. Cancel this. Go back. Next step, I'll show you how to prepare text file for land use land cover classes. Go back. This is the land use land cover classes. I already prepared. You have to prepare the land use land cover classes as same I prepared here. Value, and for the value we have 1 2 up to 10 because I have 10 classes, and land use classes we have different land uses here. Over here is starting with the forest and end up with water. WATR. It's based on the classes in your area. And to show you from where I get those information, just close this one and go to SWAT 2012. Open SWAT 2012. Okay. Enable content. Search for land use. Okay. Open here. Yeah, we have different land use, land cover classes here. Water, urban land, and all land use is highlighted over here. The same code is written in SWAT 2012 should be the same in your text file. Otherwise, it shows some error in SWAT. This also land use. Now we're done with data preparation. In next tutorial, I'll show you how to run SWAT model using the data we prepared. If you found this tutorial is helpful, like, share, and subscribe. See you in next tutorial.